Yes, good morning, everyone. Welcome back. So, we'll address one more problem from instrumentation gate paper, gate 2021 from analog electronics. Already I have answered two problems. Okay, this is a third problem. This is also an interesting one, having a T network in the feedback excited by a voltage source. That's a given problem. Okay, let me say the problem statement so that everyone can follow it. The problem is this. Assuming ideal op amp, the given op amp in the given circuit is ideal, excited by a 50 millivolt battery. Then the output voltage V naught in volts is V naught in volts is answer should be up to 1 decimal place. Up to 1 decimal place. Okay, I need to give the answer up to 1 decimal place. We'll see how to proceed for this problem and get the solution. Very simple. So this kind of problem already we practiced so many times. Okay, in fact, these are the problem in the beginning of analog circuits. Okay, we have taken for analysis and understanding of how effectively an op-amp circuit is working. Fine. So I have copy paste of the same problem here, so that will begin the solution part. So op-amp is using negative feedback, therefore it is going to offer a virtual short. So VD is equal to 0, and this point potential is 50 millivolt. Therefore, due to virtual short, this is also 50 millivolt. That means the top end of this wire is at 50 millivolt. Okay, since this is 0 millivolt, voltage across the 12K is set for 50 millivolts. Then you can find the current. Okay, so 50 millivolt across 12K will be the current, that is 50 by 12 microamps. 50 by 12 microamps. And ideal op amp, no input terminal currents. And where the current is coming from, therefore only this path to balance the KCL. So this current is also 50 by 12 micro. So 50 by 12 microamps will make a drop across this 10K. What is a drop? It will create. So into 10K means it is going to become 500 by 12 millivolts. Then this is 50 millivolt. Add 500 by 12. That is going to be this potential. Call it as Vx. So 50 plus 500 millivolt by 12. That is equal to, taking LCM as 12, then 12 into 50 will be 600. 600 plus 500 will be 1100 millivolt. That is 1100 by 12 millivolt is this potential. Then find out this current because the potential across this is Vx itself. So Vx by 1K. So that means it is in millivolt, and this is kilo ohm. Therefore, the current is going to be in micro directly. You can say 1100 by 12 microamps is this current. And this current and this current both are leaving this node. Therefore, the net current is sum of the two currents. So then if I do that addition, then it is 50 by 12 microamps plus 1100 by 12 microamps. So they have the same denominator. It is 12. Then it is going to become 1100 in plus 50. So it is going to be 1150 by 12 microamps is the total current. So 1150 by 12, okay, microamps. That's a current. Okay, any, okay. Then what's a drop it will create here? That's plus minus. The drop it will create is 1150 into 10. That means 11500 by 12 millivolt is a drop it will create. Yes, almost the problem is nearing to its end. Okay, so the goal is to find out V naught. So then let us comment on V naught. So what is V naught? This potential is Vx and this potential drop is known. Then simply add the two because potential is rising. Therefore, I can say V naught is equal to Vx is 1100 millivolt by 12 plus this drop is 11500 by 12 millivolts. So the net is equal to 1 to 600. 1 to 600 millivolt divided by 12 is your V naught. If you evaluate this, it will come something around 12,600. Let me do it once again. 11,500 plus 1100. So that with respect to the speed, we should not commit any mistake during the exam. So divided by 12. So exact value is V naught is equal to, yes, 1.050 volt is the voltage. Yes. And the beauty of the problem lies here once again. So we need to round off your answer up to one decimal. So if you round it 1.05 up to one decimal means, so what is your answer then? Answer, you round this 1.05 up to one decimal means it is going to be 1.1 volt is your answer. Okay, that's another interesting problem for instrumentation students in GATE 2021. Thank you. So I'll update with one more analog paper. Okay, so